let me show you this running. You can't run this in Cloud 9, by the way. So we've got this main function. I can't just build the main. I've got all those other CPP files there. So what I can do is use star.cpp to compile all those together. But that won't work because there's a library dependency. So I have a script here, build.sh. Oops. And this is, see, there's the star.cpp right there. This is get all the CPP files and build them together, compile them, and link them. And then there's a bunch of settings to include in there. And then after it's built, then go ahead and run the executable. So that's just some fancy script I wrote there, okay? It'll look like this. So this is all the program does. I use AWS&D to move this block, a step at a time. That's it. Okay, so how do we do this? And then if I hit the escape key, it closes everything. So it's the beginning of a simple game. And the source code is here. It's based on this library called SDL2. So I want to go to the home page, not this one. So libsdl.org. And this is the older one, 1.2. The newer one is 2.0. This is the one I'm using. This is for downloading. Here's the documentation. The documentation is pretty compact. There's a wiki here, and you can look at the API. API stands for Application Programming Interface. So it's got a list of functions that you can call. Oh, look at here. SDL is written in C, so it's a C language. But it works natively with C++. So you can mix it with C++ code without any problem. Because you can think of C as a subset of C++. So anything that's written in C, you can just embed it inside of a C++ program. Normally it's just as simple as that. Sometimes there's a little difference that you've got to take care of. And so we've got some links here. This is the wiki on it, okay? But when you're coding, you're going to tend to go into this API listed by category I usually use. So some basic functions here. Functions related to video. A functionality related to input events. That means the keyboard key presses, mouse movement, mouse clicks, joystick movements, controller inputs from a controller, like an Xbox controller and so on. So that's input events. And then force feedback. This is, well, it says SDL haptic, so that would be like vibrating the Xbox controller, when there's an explosion. That's called a part of a haptic system or interface. I don't know much about it, but that's that. Then there's an audio functionality here. Something to do with managing threads. So a thread is it's a sequence of executions of operations. And usually programs, or not usually, but frequently programs are multi-threaded. So you might have some sequence of operations performed in one thread, while in parallel you've got another sequence of operations being performed. That's called multi-threading. So there's some functionality related to that. Timers, files, how to interact with the file system, retrieving files. Maybe for video games, you've got things like game saves. How do you save the state of the game in a user's local file system? You'll need to do that. And shared object support, I don't know what that is. CPU information, I've never really used it. A little bit, actually, this in here. Power management for cell phones. And some extra stuff here. So here's the basics, initialization and shutdown. It looks like this. There's some text in here. It talks about how to initialize the library. Then there's a list of functions. Here's the init function. It gives the function signature right there. See, this SDL init is the name of the function. It returns an int. And it takes one argument called flags, and it's of type unsigned integer 32 bits. And the flags are so on. So it talks about things. And it has an example here. How to call SDL init. What does it do? It's done right here. So I use this to get that application running that I just showed you. You know, this grid. So how do you do this? Well, I had to draw the lines, and then I had to listen to the keyboard events and respond to them by moving this box, and I had to draw the box. And then I'm listening for the escape key press, so I need to exit the code that way. And it's inside, the starting point is main, so there's a main function here. And the main does three things. It calls the initialization function. Then it calls a loop function. And the program stays in the loop until the user hits the escape key, or if the user closes the window by pressing the X. And when the user exits the game in one of those ways, then this shutdown function runs. And that's the end, and we just return. So we return 0 because main returns an int. That's optional, we could leave that out. And then, so then it's just a matter of, well, what do we do inside init? What do we do inside the loop? This is loop. This is the loop function right there. Just while process input. So this function, process input, what it does is there's an input queue, a queue of input events. So when the user moves the mouse, it generates a whole bunch of mouse positions. So as you arc the mouse, say, across the screen, that's not one event. The computer breaks it down into lots of little events. Just like, the mouse is here, now the next moment the mouse is there, then the mouse is there, then the mouse is there. So you've got this list of mouse positions. Maybe you press the T key, when the key is pressed down, that's one event. And when the user releases the key, that's the second event. When the user moves the mouse wheel, that's an event. How far does the wheel go? Could be multiple events there, so on. So, and all these events go into this queue, and they wait for us to pull them off the queue and process them. So the processing of these events is all placed inside this process input function. So we call the function, and we say, function, go ahead, read through all those events and take whatever action you need to take based on what's happening. And when you return from process input, see, this is a function, so when it returns some value, unless it's void, but this is not void. Process input returns a bool. And it returns true to tell the loop to continue looping. But if the process input function detected the escape key being pressed, or the Windows X key being pressed, clicked, then process input returns false. And false will break this while loop. So process input controls when the loop stops. And then inside the loop itself, it just calls draw. It says draw, and then delay 50 milliseconds. So that's an infinite loop. So this is called the game loop or the simulation loop. It's very simple. I made this code just very, very simple just to show in this 201 class. So of course we'd have to look at process input, and we'd have to look at draw and see what those things do. But we also have to look at init. Now of course shutdown is simple. So shutdown is just calling a couple of SDL shutdown functions. Let's take a look at init. Here's init. This initializes a new window. So the first thing we do is we call SDL init and tell it, it's got these subsystems. It's had an audio subsystem, a video subsystem. It's got a bunch of subsystems, and we just need video for what we're showing now. But we could initialize all of them if we wanted to. If SDL init returns a negative value, it means there's an error. So we have this function called SDL error. It just says handle whatever SDL function just occurred. So we check to see if SDL init returns a negative value. If it does, we'll call SDL error. And SDL error, by the way, will shut everything down. Let's take a look at SDL error. Oops. Where is SDL error? There it is. Here's the function SDL error. SDL stores its most recent error information internal to itself. So to get that information, we call this SDL get error function. And we're just going to print that out. So it's a message. We print it out, and then we call exit. So this is to terminate the program without returning through main. Exit and return a value 1. So 0, when we return a 0 from main, it means everything was okay. But if we return a non-zero, it means there was an error. So we're not returning through main. We're exiting the program abruptly because there's some kind of an error. Something is wrong. We're just going to shut it down. We're going to try to print the message here, and then we're going to shut down right there. Essentially, we're returning a 1 from this point instead of going back through main. So that's, and then we do things like we create this application window. So, SDL create window. It creates the application window. See, this is the application window. Do you see that? This console program is an application. This is a browser window. That's an application window, right? The operating system gives this to you. It gives you these tabs. It gives you these lines. It gives you this X, these little icons here. And so we can get that by calling this SDL create window function. Now we could interact directly with the operating system to get a window, but we don't because we want this code to be cross-platform. We want to be able to write it so it compiles and runs on a Mac, Linux, and Windows. So SDL, the essential benefit of using SDL is it gives you a layer of an abstraction layer that lets you deal with all the different systems in the same way. So if you're on Linux, you call SDL create window. If you're on Windows, you call SDL create window. So you make the same call with the same arguments. The arguments have the same meaning across all the different platforms. So it gives you portability, makes your code portable across those platforms. So you write, your game logic or application logic in this sort of cross-platform context. So the first argument to SDL create window is the window name. So I'm going to call that test. The second argument is its position in the screen. So we're going to tell the window to be centered. So this is the X position, this is the Y position relative to the screen. And then after that, we're going to pass in this other information. This is the width of the window. So I want it to be columns times cell size. And the height of the window, which is rows times cell size. And then the last argument is some flags, and we're not asking for anything special, it's just a 0. So let's look at that. You'll see the window, it'll have the name test for the window. It'll be directly centered in the screen. Let's take a look at that. So we build it. You see this window, this is the application window. It came up directly centered in the screen. And you see we get these things. We didn't, this is given to us by the operating system. And this here, the operating system doesn't actually close the window. We're the ones that have to do that. So I wrote the code to do that. Now, maybe we didn't want it centered. We want it to be, to the upper left-hand corner. So, give it a 0 for the X value and a 0 for the Y value. So it's going to be pushed up into the the application window will be pushed up to the upper left-hand corner of the screen. You see that? Okay. So that's how that works. Oh, one other thing is see the test here? That's the window title. All the 3 different operating systems, Linux, Mac and Windows, they all have the same window organization. They all have windows. The windows have titles. The windows have these controls over here. This is minimized, by the way. I don't think that does anything. Oh, no, it does. Take that back. That does work. That will work. So that's handled by the operating system. I'll make that centered again. And this is the size of the window. We could make this different. We would make it tiny, make it 100 by 100. Of course, it won't fit the grid anymore. See that? So now it's, but I'm going off the edge there. I have to come back. Oh, it's lost. Now I can find it. So that's basically what you get. You get this this API, Application Programming Interface. When you call create window, you get a pointer to a window struct or a window instance, and we're save that. I'll show you. That'll be up here. See the window? It's the variable window. It's of type pointer to SDL window. So you see a lot of pointers. In C, now SDL is a C language, so there are no references. So you just have pointers. So you have to manage pointers. So we have a pointer, a reference to the window. We have a reference to this thing called a renderer. That's the thing we use to draw the lines in the square. You get a reference to, look, a grid class. See, that's uppercase G. That's the naming convention. See this? I wrote a grid class, put its declaration grid.h. And then during initialization, we create an instance of the grid class, and then we save a pointer to it, so we can access the grid as needed. Then we have a player class. That little box that moves around, it corresponds to the keystrokes. All the logic for that is contained in a class called player. So we have a reference to, or a pointer to a player instance. So you can see SDL is in C, the C language, but the logic that I'm adding to make the program work is written with classes. So I'm using C++ classes. And for video games in particular, you just see so much of this. You just see a lot of classes. You'll see, oh, that's the player class. You know, if you want to do something with the player, like I want to make the player move faster or something, then you would know to look in the player class. You would start your search and your analysis of how to add the extra functionality by looking in this player class. So this look inside initialization, this is where we create the grid instance and the player instance. But no, we haven't used this new operator. What we did in our code is we would do something like this. We go grid, right? And put the arguments like that. This is how we were creating a grid instance like this. We invoke the grid constructor, and then we have this grid instance. Now this grid instance, its data is stored on what's called the stack. So it's memory, it's RAM memory, but it's in this thing called the stack. And when you return from init, see, when you return from init, this grid instance goes out of scope. It's no longer valid. If you want the grid to persist beyond, the call to init, you have to create it outside the stack, what's called the call stack. It has to be created in the heap, in the non-stack memory. And that's why you use the new operator here. So we want to create an instance of grid and have it exist in memory that's not invalidated when you return from the function. Now the new operator, this new operator invokes the constructor just like the syntax we've been used to. The new operator invokes the constructor and then returns a pointer to the created object. We're going to store that pointer into the grid instance here, into the grid variable. And here we create a player object, and so on. So the purpose of the grid is to well, let's look at the grid. Here's grid.h. It's got a draw, so it draws the lines. And it has a cell size in it. So internally, look at the class. It has to store how many rows there are in the grid, how many columns are in the grid, what is the cell size. And then we also, just for convenience, we store a pointer to this SDL renderer, so that when the draw function is called, we use this renderer pointer to call functions on it to draw the lines. Then we have a convenience function here for other code to use called get cell size. So that's being used. Look at the grid implementation. See the draw function for the grid class? So we show the implementation here. We're defining this external to that, that grid declaration block. So we want to call the SDL set renderer draw color function. So before we draw the grid, we got to say what color it is. So this is RGB. A, that's an A for alpha. So it's red, green, blue. It's red, green, blue. Let's turn the grid into blue. Okay. So I'll set the red value to 0, the green value to 0. I will leave the blue value at 255. Okay, now the grid is blue. See that? Anyway, that's how you do things. And it needs a renderer. Now, if this was object-oriented, I got to tell you, if this code was object-oriented, we would do something like this. We would have the renderer pointer and invoke the set renderer draw color and pass it in arguments like that. That's how that function would appear in an object-oriented program or an object-oriented API. When I say object-oriented, I mean based on classes. So we'd have a reference to an object called a renderer, and the renderer would have a function, and probably it wouldn't have SDL there. It would look something like that. But SDL is a C library, so it passes around as this first argument something that functions like the object in an object-oriented design. And then we just iterate through the rows, and we draw a line. So we use this SDL render draw line function to draw a line. And then we iterate through the columns and and draw the vertical grid lines. So that's it. There's the files, and I provided a link if you wanted to play with that. This is what this is stored in something called a Git repository, which is public, and you can retrieve the source code from there if you like. Here's the player class. See, it's got a process event function in it, and it checks to see if the D key was pressed. If it was, then we increment the X position of the cell position of the X coordinate of the cell position of that little square that represents the player. So it goes on and on. One last thing I want to say, I'm going over here. It's very hard to set up the development environment. Like, oh, okay, I've got a library, where do I store it? How do I access the header files? How do I link against this? To getting it configured and to set up your build environment, it takes a lot of skill, a lot of knowledge, and tinkering. So if you want to work with SDL and you're don't know what to do, then come and talk to me and I'll help you get it set up, whether you're on Windows or Linux or Mac. I mean, it's not impossible, but it's something that's that relies on information that we haven't talked about yet in this class. All right, that's